actually, we have come to the end of this section. There are only 4 examples. Yeah, I wonder why. Now for homework, please do problem 7, 25, 33, and 47. That's it. Okay, 1 for each example. And when you're done, I will talk about all of them. So first, let's look at problem 7. On page 733, we have problem 7 is 3x minus 79 over x squared minus 5x minus 24. For this, please refer to example 1. Okay, we're going to follow example 1 as the model of solving this thing, which is example 1 is on page 726. This is it's very important in this section that we copy the examples exactly, and that way we do as little work as we can possibly get away with. Okay, so example 1 has something that's like this, except it got factored. So let's factor this thing. Okay, this equal to 3x minus 79. I guess I'll write that down. And then the denominator factors into let's see, we'll write down these things. So that's 24, and it has to achieve 5. Well, if we have 3 times 8, that's 24, and 8 minus 3 is 5. So to have a minus 5, we will have minus 8 and plus 3. Minus 8 plus 3 is minus 5. And then the 3 times negative 8 is negative 24, so that works out. Yeah, okay, so that's the easy part. Now we're going to follow exactly example 1, okay? And looking at example 1, here's what they did. Example 1 says we'll pop it over a over one factor and b over the other factor. All right, so that's what we're going to do. So this equal to, this will equal to a over the first factor, x plus 3, and then plus b over the other factor, x minus 8. Okay, so that is, so now that we know that we have copied down the method, okay, now we just have to do it. Now to multiply this stuff out to have the same numerator as that, then the numerator will have to equal to a times this thing, okay, a times x minus 8, and then b times that thing plus b times x plus 3. Okay, so then this numerator divided by this denominator will end up being this thing. And yeah, because these parts will cancel out respectively. Anyway, so let's do this. This will be equal to, and that will be summing up all the x's. It will be a plus bx plus bx. And then, and after x's is just numbers. The numbers are minus plus, let's see, minus 8a plus 3b. And this has to end up being the original numerator. See, this is the numerator, and they has to be the same. For it to be the same, then a plus b has to be 3. And then this minus 8a plus 3b has to be minus 79. So we have, so we'll write that down. A plus b had better be equal to 3. And then the minus 8a plus 3b need to be equal to negative 79. Okay, so then we're going to multiply, we'll call this equation 1 and equation 2, and we're going to do our simplification trick. We'll do, say, multiply 1 by 8, okay? So equation 1 times 8 gave us 8a plus 8b equals 8 times 3 is 24. And then we'll add these things together. Then these disappear. And then we have, this becomes 11b equals to positive and negative, that should be 55, which give us b equal to 5. Okay, and since a plus b equals to 3, that means a had better be minus 2. All right, so that, and so that should be our answer, okay? We'll call a minus 2, And B equal to, what was B? 5? Yeah. And that should be the answer to our problem. Let me check. Well, my answer is wrong. Why? Because minus 79 plus 24, there's a minus here that I'm dropping the minus again. Why am I always doing this? Well, anyway, so that has to be fixed. Okay, so B is minus 5. If B is minus 5, then A is equal to something else. Let's see. B is minus 5, then A is equal to 8. Okay, so because move B over here, 3 plus 5 equals to 8. Ah. Anyway, so B is minus 5, and that means A equals to 8. All right, so that is so hopefully you didn't forget the negative sign the way I did. How did I even forget it? I don't know. Anyway, so that is that, and that is problem 7, and now it is correct. So next, let's do problem 25. We have 5 minus x over x minus 7 squared. Now there's a squared here, and that matters. How are we going to handle the squared? For this, please refer to example 2, which is on page 728. So we are going to copy exactly what they do on page 728. Now specifically, on page 728, we have on the denominator, that's the only thing we care about really. We have on the denominator there's an x, okay, and then there's an x minus 2 squared. So besides the squared, there's also an x. Now in this case, we don't have an x, and which means we don't have to pay attention to that part. So we're gonna write this as it says. We're going to write down there's no x, so we can ignore the a part, okay? And so we'll only write down, do the b and c. So this equals to let's see, b over x minus 2, and then plus c. Sorry, not x minus 2. In our case, it's 7. X minus 7. 7, please. All right. So we'll do b over x minus 7, and then c over x minus 7 squared. That's the plan. See, this is a very exact trick that you have to follow, and if you follow the trick, everything will come out. So that's, and you say, well, do I have to memorize this? Nah, I wouldn't. I mean, I don't remember this. I don't see why you should. And just this is just something you will later know how to refer back to if you ever need to do this again and say, oh yeah, I did that some way, somehow, okay? And then you can look it up and know exactly how it's done. So right now we have, so we have no a because there's no x here, so we don't need to worry about a. So we only have b and c to think of. Now having said that, then let's do that. For this thing to add up to be that, the numerator will have to be this thing will have to multiply by x minus 7. So we have b times x minus 7, and then c doesn't have to do anything because c already have the common denominator, which is x minus 7. So we'll just have plus c. And that means, so then the whole thing add up to be bx minus 7b, and then plus c. And that means b has to be the minus 1, because b is the coefficient of x, see? So b equals to minus 1. So we got that. And then the next part is negative 7 plus c has to be equal to 5, which I'll write down right here. Minus 7b plus c has to be equal to positive 5. And since b is, what did we say b is? Minus 1. Okay, so that means times negative 7. So 7 plus c has to be 5. That means c is minus 2. And that should be the answer. Now let me check first. Minus 1 minus 2. Yep, that is correct. B is minus 1 and C is minus 2. So we'll write down B as minus 1 and C as minus 2, and that is the answer to this question. Okay, an easy one. See, only required one page. I mean, one side of the board to do it. All right, so now that's it. So now I better erase this for the next problem. So next, let's do problem 33, which has, this is looking more and more complicated. We have an x minus 1, and this thing cannot be factored out because 1 times 8, 2 times 4 is a plus, so it's just going to be more than 3, okay? When you add it up, 2 plus 4, this is not factorable. So then we are going to do it this style, okay? So let's look at example 3 on page 730, because that has a problem that looks exactly like it. See, here's example 3 on, where's my example 3? Right there. All right, see that? That looks exactly like it, so we're going to do exactly what they say. And the way we're going to do it is we're going to take a over x plus 3, okay, because x plus 3 has only 1 power. And then the other thing that has 2 power, we'll stick bx plus c on it, just like they have it here. So let's do that. So copying this thing, okay, we will imitate this thing exactly. A over x minus 1 in our case, and then plus bx plus c divided by this stuff down here, which is x squared plus 3x plus 8. All right. So now that we have followed the plan, now we just have to multiply it out. Now the numerator it will be equal to a times this stuff, okay? A times all of that, x squared plus 3x plus 8, and then the bx plus c will be multiplied by that thing. So bx plus c being multiplied to x minus 1. Okay, that should be right. And so now with that we have let's multiply this part, or let's multiply the whole thing out, I guess. So that will be ax squared, and then plus a times 3x, and plus a times 8, or 8a, plus this times that is bx squared, okay? And then bx times minus 1, that's negative bx, and then plus cx, and then minus c. So we have all that stuff, okay? And then we are going to, right. So let's write out all the coefficients. First, let's hunt down all the x squares. We have a and b. So a plus b has to be the coefficient of x squared, okay? And which is negative 2 right here, minus 2. Next, let's do all the x's. So we have a 3, so 3a, and then another x anywhere, minus b, and then plus c, and that is equal to, what's the x? Is 10, equal to positive 10. And the last thing is all the numbers. We have 8a, and then any more numbers? Minus c, and that equal to 4. All right, so now we have famous 3 equations with 3 unknowns, okay? And we'll do it like we did before. 1, 2, 3. Yeah. Anyway, so looking at these, what is the easiest thing to crack? Let's add equation 1 with, if we add equation 1 with equation 2, then we will, we'll get rid of the b. So let's do that, why not? So adding equation 1 with equation 2, is that going to work? We will get rid of b, and then that will get rid of c. Well, whatever. Let's see. Yeah, that is Let me think about this. Actually, let's get rid of the C because we already have A and B here. So if we get rid of C, we'll have another A and B. And with two A and B's, life will be easier. So we're going to add these two together to get rid of the C, right? There's a plus C and a minus C, so let's add them up. So adding equation 2 plus equation 3, we get 3 plus 8 is 11A. And then minus B. And that will be, and then plus the C's disappear, equal to 10 plus 4, that's 14, okay? And then we'll write down equation, then this will be called equation 4. See, this is just like the previous section, and yeah. Anyway, so next let's add equation 4 to equation 1, because there's a plus B there and a minus B there. So let's do equation 4 plus equation 1, and then we get 11 plus 1A, that's 12A, and then plus B minus B is gone, that's good, minus 2, and then 14, that it will be positive 12. Let me pay attention to the negative sign here. Now that I pay attention, there isn't one. Anyway, so then A equals to 1, that's good. And what's B? 1 plus B is negative 2, so B is minus 3. Okay, put the 1 on the other side, is minus 3. So B is minus 3. And then C equals to, from equation 3, okay, we can calculate from equation 3, put C on the other side of the equation. So then 8A, that's 8, minus 4 equal to C, which means C equals to 4. So that should be it. We got, so from my answers, let me check, okay? What problem is this? 33. It says I got A equals to 1, B equals to minus 3, and C equals to 4, or something. Yep, right here. All correct. Yes. Okay, so A is equal to 1, B is equal to negative 3, and C is equal to 4. Okay, now I'm sure that a regular math teacher will require you to write this stuff out properly instead of what I'm doing right now. But I don't really want to write any more than I have to, so let's just call this done. Okay, but you yourself should ideally write out the answer properly. Yeah, anyway, so in other words, do as I say, not as I do. So next, let's look at problem 51. I know that when I was in the earlier, I mentioned problem 47, but let's not do problem 47. Let's do 51 instead, because there's something wrong with 47. I didn't notice it when I was assigning it. So anyway, let's do problem 51, which says, okay, now problem 51, as you can imagine, please refer to example 4. Okay, which is on page 732. So see example 4 on page 732, and because they are the exact same kind of problem, and so that way we can do it exactly the same way. See, here's example 4. As you can see, yeah, look at the denominator. Okay, it's almost identical. So we're gonna pull the same trick. Well, what we're gonna do is have A over X. Okay. We also have an x here, and then and b over bx plus c will be over the x squared plus 4, just with one power, and then there's yet another dx plus e that will be over the thing squared. So we have, yeah, we'll have 5 variables. That is tedious, but that's the way it is. Okay. Okay, so let me write that down. So this will be equal to a over just x, and then plus bx plus c will be over one of these things, okay, x squared plus 4, just one, we don't have to square it yet, and then dx plus e will be squared, will be over the squared version. And with that, then we will be able to calculate, make everything come out, hopefully. All right, so that is that. A bx plus c dx plus e. All right, so squared. Now to do that, then we're going to do the same thing we did in example 4, which is we're going to multiply everything with the until everybody's got the common denominator. So the numerator will, I'm only going to write down the numerator, and will be, we have a over x, so we need to multiply by the square. Okay, so a times x squared plus 4 squared. All right. That's a bit faint. I don't know. Anyway, so then, and then plus bx plus c has to be multiplied by this thing, x, times x and x squared plus 4. And then finally, the last term, dx plus e, is going to be multiplied by x plus e. That will be multiplied by just x, okay? Because it has this thing, but it still needs that. So that is that. All right, so now that we have that part, let's multiply this thing out. Let's see, so this is a times x squared, okay, plus this is, no, fourth, sorry. So x squared times x squared will be x to the power fourth. Let's get rid of that. Okay, so this is fourth. And then the next one will be x squared, will be 8. 4 plus 4 is 8. 8ax squared, okay? And then 16a. 16a. And then this thing, we have to multiply it out. And we just multiply that times that with an extra x added and multiplied to it. So bx times x squared is equal to bx cubed. And then one more x will be bx to the fourth. Next, bx times 4 is 4bx. So 4bx. Except that there's another x multiplied to it, so 4bx squared. And then next, c times x squared is cx squared. Except that we have one more x, so it becomes cx cubed. And then finally, c times 4 is 4c. 4c, except that there's an x being multiplied to it. So that's that. And then next, we do this one, dx times x, that is d times x squared. And then e times x is e times x, ex. All right, so that is a big long thing, but it includes all of it. So now we are going to figure out what is x to the power fourth. And how many, for x to the power fourth, we have a, right there, okay, plus b, a plus b, and then that's fourth. I think that's it, yeah. A plus b, there's nothing to the fourth power here, so a plus b has to be equal to 0. That's the first one. Next, x to the power 3. Any x to the power 3 here? Right here, we have cx3. So c, any other x to the power 3? I'm not seeing it. So c has to be equal to 0 because there's no x to the power 3 here. And next, x to the power 2. We have 8a. So 8a x to the power 2. Any more? Plus 4b. Plus 4b. And then x to the power 2. Any more? Plus d. Plus d. D is x to the power 2. Okay. X, there's nothing that's x to the power 2. So that, again, equal to 0. So next, we have just x. Just x, where's just x? Just x, just x, right here. 4c. 4c plus e. Plus e is just x. Just x equals to 5, okay? The coefficient of just x is 5. Now, from this point, we know that c is 0, which means e equal to 5. So we got this part. So e equal to 5. And next, constant terms. This is 16a. 16a. Any more? Constant, 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 constant. No, I'm not seeing it. Yeah, I only see this. Okay. All right. So 16a is equal to 2. So then a has to be equal to 1 over 8. All right, so now let me check to see how good I'm doing. All right, and let's keep going. I got this right. I don't know about the others. So, so then we have, so far we have A and we have E, okay? So we got A and E. I don't know if E is right. I only checked that A is right. E could be right. Let's hope it's right. And then we got, and we also have C too. Let's say that these are right for the moment. So that means we know what B is. B is A, because A plus B is 0, then B has to be negative 1/8. B equals to minus 1/8. All right, and then so we have A, B, C, E. We need D. D is from here, so we have to calculate what D is. What's D? Let's do the, okay, let's D. Then from this equation we get D equals to minus 8A and then minus 4B, which is minus 8A is minus 1, okay, because A is 1/8, minus 4B, where's B? And minus 4 times B, minus, and B is minus, so it becomes a plus 1/2 is what I got. All right, and that is equal to minus 1/2. That is equal to D. So D is minus 1/2. All right, so what do we have here? We have then A is 1/8, so A is equal to 1/8. We'll write 8 on the bottom, okay? And then B and C, C is 0, so C is gone. B is minus 1/8, so this is negative 1 minus 1/8 times this stuff. All right, and then D, what was D again? D is negative 1/2, so D is minus 1/2. Yeah, and well, can't really write it that way. Let me erase that. Right. We'll just write down, what was D again? Minus 1/2. We'll just write it that way, okay? For now. D is minus 1/2. Minus 1/2 is D, and E is 5. Okay. So the answer is, let me see, 51 is 1/8x. That part is good. And then x over 8x squared plus 4. Okay, so that part is still good. And right here it says, okay, so we'll have to rewrite this part to look like the answer. So this part is basically says that is minus 1/2 x plus 5, okay, divided by x squared plus 4 squared. Now to make it look like the answer in the back of the book, we'll do this. Let's see, I'll get rid of some of this stuff. What we're gonna do is this is gonna be rewritten as minus 1/2 times x plus 10, okay? Because minus 1/2 times x plus 10 is exactly negative 1/2 x plus 5. Actually, it should be x. I'll only factor out the minus half, okay? We'll keep this in there, so we don't mess with the negative sign. So then this 1/2 over x squared plus 4, and then we can just write down the 2 down here. So the answer will be minus x plus 10 over 2 times this stuff. And that is exactly what the book says. Or 10 minus x, same thing. So this is the, okay, so with that we have finished problem 51. And that should mark the end of this section. Yeah, this is getting a bit tedious, right? But the next section we're going to talk about matrix. And that is, in a sense, even worse. So let's do that.